Hello students, this is Mr. Deaver, and in this video I'm going to talk about conjugate acid and base pairs. Now, before we can get too deep into things, we have to talk briefly about definitions. Going all the way back to ancient Greece, people had some basic knowledge of acids and bases and began to categorize them into sour-tasting acids and bitter-tasting bases. But it wasn't until 1887 when Sponte Arrhenius proposed the first useful definition of acids and bases. Now, as a side note, even more interesting than his work on acids and bases, Arrhenius was the first person ever to propose, way back in the 1800s, that human-produced carbon dioxide emissions can cause global warming, an idea that obviously has become very important and relevant. Now, even though Arrhenius is great and all, we're actually not going to look at his definition. We're going to look at the Bronsted-Lowry definition of acids and bases. And according to them, an acid is something that donates a proton or an H plus ion, and a base is something that accepts a proton or an H plus ion. So make sure you write that on your note sheet. Now, this is interesting because it means that the substance that's produced after an acid has donated its proton is actually a base. And a substance that's formed when a base accepts a proton is actually an acid. Okay, what the heck does that mean? Well, let's look at an example. Let's look at this example, okay? Now, in the reaction going from left to right, we have HCO3 minus donating its H to H2O, which means that HCO3 becomes just CO3. And H2O accepts an H plus to become H3O plus. So going from left to right, it seems like HCO3 is acting as an acid because it donates its H, and H2O is acting as a base because it's accepting an H plus. Now, remember though that this is a reversible reaction, and we use a double-sided arrow to show that. This reaction can happen from left to right and right to left, and in fact, both reactions are happening at the same time all the time. If we look at the reaction from right to left, H3O plus is donating an H to CO3 2 minus, which means that H3O plus becomes H2O. H3O plus is acting as an acid because it's donating an H. And CO3 is accepting that H to become HCO3 minus. So CO3 is acting as a base because it's accepting an H plus ion. Okay, so key idea. Going from left to right, HCO3 gives up its H, which makes it an acid. But once it becomes CO3, it's now capable of accepting that H back, which makes CO3 a base. So we can see that HCO3 and CO3 are connected. So they form what we call a conjugate acid and base pair because they're two substances related by the loss or gain of an H plus ion, a hydrogen ion. H2O and H3O plus are also related. H3O plus donates an H, which means that it's acting as an acid. H2O could later accept that H back and become H3O plus again, which means H2O is a base. They're another conjugate acid-base pair because they're related by the loss or gain of an electron. Sorry, the loss or gain of a hydrogen ion. Now, two quick side notes. Even though this reaction is reversible, there may be one reaction or the other that's highly favored. So depending on the specific reaction, we might see a high concentration of products and almost no reactants, or we might see a very high concentration of reactants and almost no products. Or maybe neither reaction is favored much one over the other, and we see a mix of reactants and products. What happens will depend on how strong the acids and bases are on each side in the specific equation and how much they want to donate or accept an H. Another side note here is you may notice that H2O here is acting as a base. That may surprise you because perhaps you've heard before that water is neutral. Well, It's true that water, or H2O, is neutral, and we're going to talk more about that next week when we learn about pH. But it's also true that in acid-base reactions, water can sometimes accept an H, and it can also sometimes donate an H. Water is called amphoteric because it's capable of acting as both an acid and base. Okay, let's look at two examples here. And the key question to ask ourselves when we're going through these is, who is donating an H to whom? Whoever donates the H is the acid. So going from left to right here, who is donating the H? Well, we can see that, well, is it HF giving an H to H2O? Or is it H2O giving an H to HF? It looks like it's HF donating an H to H2O, which turns HF into H minus. So HF donates an H plus, it is an acid. H2O accepts that H, it's acting as a base. Going from right to left though, well, we can see that F minus doesn't even have an H to give, so it can't be an acid. H3O plus gives its H to F minus, which turns H3O plus into H2O. H3O plus is donating an H, it's an acid, and F minus is accepting that H plus, that hydrogen ion, it's a base. Now notice on the right side I wrote Ca and Cb for conjugate acid and conjugate base. Technically there's really no difference between a conjugate acid and an acid. They're both just acids. And there's no difference between a conjugate base and a base. They're just both bases. But we're going to identify things on the right side of the equation as conjugate acids and conjugate bases to emphasize this relationship between the substances. HF and F minus are a conjugate acid and base pair because they're related by the loss or gain of a hydrogen ion. So the two substances on the left we're always going to identify as an acid and base, and the two things on the right we're always going to identify as a conjugate acid and base. Okay, one more example, and again, the key question is, who gives the H to whom? Well, going from left to right, we can see that HCl gives its H to NH3, which turns HCl into Cl minus. HCl donates an H, it's an acid. NH3 accepts an H to become NH4 plus. It's accepting an H plus, it's a base. Going from right to left though, NH4 donates its H to Cl minus and turns us back into NH3. So this is acting as our conjugate acid, or an acid, and Cl is accepting an H, so it is our base. And remember, since Cl minus doesn't even have an H at all, it can't possibly be an acid. Anytime you see a substance with no H, you know automatically that it's a base. If it's on the left, it's going to be our base, and if it's on the right, it's going to be our conjugate base. Okay, there is more practice for you to do, and then you can check your answers. Good luck.